All right. Hey, everybody. I'd like to welcome you back. We're back here in October. Luckily, it's sunny out here in Florida, but I imagine it may be getting colder wherever you may be in the world. I hope everybody's staying safe with everything that's been happening. Everybody stay safe. And today we're going to have some great talks about audio programming. So this is something that we do every second Tuesday of the month. We have two speakers, and we got some special ones for you today. Just a little reminder before we get started that we have the audio programmer community. So we're running up on 10,000 members strong in our audio programmer community. For the past 6 years, we've been helping thousands of people to get into audio software development and learning to take their first steps and helping to level up their skills, because we have a lot of professionals in there as well, with creating plugins, creating audio applications, and it's been fantastic to see. So you can join that on the audioprogrammer.com/community. We also have a recruitment service that we do for recruiting for companies, also contracting for software developers. So if you're looking for an audio software developer, come talk to us at the audioprogrammer.com/recruitment. Okay, let's go ahead and jump into our first talk. So our first talk is coming from Chris Roberts. So Chris is an independent software developer with almost 40 years of experience. And today he's going to take us into the world of Juice and the ValueTree class. And the title of this talk is ValueTree Wrappers, Data Model Without Dealing with Value Trees in Your Client Code. Over to you, Chris.
Thanks, sir. I think I'll talk about how I came across what I'm calling a ValueTree wrapper architecture. About 5 or 6 years ago, I'd been using Juice for a long time, but I hadn't really used ValueTrees, working on a project where they wanted to have undo and redo available. And I had recalled, oh yeah, ValueTrees, get that for free. And so I went and watched Dave Rowland's great ValueTree talk. If people haven't watched that, pretty fantastic as a primer of not only how it works, but an example of how the changes for them really reduced their technical debt and stuff like that. So then after using it for a while, I started seeing some patterns around how I was using it, and that I had to be writing a fair amount of ValueTree related code in all the client code that was using ValueTrees. And so I started working on the idea of using ValueTrees to represent my entire data model, and passing a single value tree down into all of the client code, from which you could obtain access to the data that you needed using one of the ValueTree wrappers. A ValueTree wrapper is a little boilerplate class that you write that is kind of what I would call domain specific, having a set of setters, getters, and callbacks. Internally, of course, those member functions of the class end up manipulating your value tree for you. The basic, outline that I use is, of course, setters are all called set, getters are the gets, and then the callbacks are the classic on X changed type callback. So I've been working on it about 4 years now. Had some cruftiness to it that I wanted to clean up so that it would be more useful. And a lot of that was about how to set it up and use a class. And so I ended up using CRTP, the curiously repeating template pattern, to solve my issue. And much cleaner usage now for that. It's really lightweight. Again, you don't pass the wrappers around, you pass value trees around, and then locally you use wrappers to access your data. It helps to really enforce loose coupling of your classes, of your codes, so you're not passing around pointers to classes and using those to communicate. As I was saying there, at startup, the application creates a single value tree, which is the root. And then in the way I'm using it, I have two branches off of that. One is the persistent data and one is the runtime data. anything that you put onto the persistent data branch will be automatically written out to the application properties file. Anytime it updates, a write is scheduled and then will happen a second or two later. And the reason that it's scheduled and not executed immediately is because you could have something like the value of a slider being saved in that properties file, and you don't want to write it out for every change of that slider value.
Can you show us some example code? Do you have some examples?
Yeah, I want to talk about a couple more things, and then I'm going to pop into code.
Oh, okay, great.
Yeah, and the value tree that you pass into the wrapper can either be the object itself or the parent of the object, which makes it really easy. Again, you know, a lot of things are just attached either to the persistent or the root, and so it's really easy to just grab the or the runtime. I mean, not the root, the persistent or the runtime. You know, grab the one you need and stuff it into your wrapper, and it will find the child just one level down. Find the child of that wrapper and provide it for you. When you wrap a value tree as well, you indicate whether you're the owner or the client. The client will expect it to be there, and we'll have in the debugger, we'll throw an assert actually if it's not. And an owner will create the data if it's not there. Yeah, that's that. So let's go and actually just look at a quick value tree wrapper class. So I just put this into an app I'm working on yesterday for storing the window location and the size of the panes within the application. So we're creating a GUI's property class. I got to share my screen, don't I? There we go. So this is a simple value tree wrapper class. Like I say, I store the position, size, and the pane sizes are the three things that this is managing. So my three setters, my three getters, and two callbacks. I haven't used the pane size callback yet, but I'll add that in. And then these identifiers are used for the value trees. Again, just a convention I use. The name of the value tree object I call the type ID, and then all of the properties within it I call the property IDs. So again, we'll store position size and pan sizes. There's two functions that you can define for your value tree wrapper, and that is a init value tree and process value tree. A init value tree will initialize the data, the properties and children for the wrapper class type, and process value tree will, after you've wrapped it, process value tree will be called. One of the uses that I find for the process value tree is if you've changed persistent data and you want to remove old children or old properties from that persistent data, this is the place you can do it. So it's kind of a versioning kind of thing that you can use. It also can be used for other things, like for this GUI class, I actually initialize data to certain values for defaults if they don't exist, i.e. you've loaded the tree and this value tree wasn't saved, and so you get your defaults from there.
Chris,
yeah.
Would you mind making the text a little bit bigger? Just some users have asked for that. There you go. All right.
Perfect. Yep.
All good.
Yep. Yeah. And the other thing that I do, and this is a good example of it too, this works great for single values because a value tree property can receive a callback when that value changes. And so to bundle up two values like the X and Y position or the width and height, I pass them in together. I actually convert that into a comma separated string, and I store that in the value tree. And the callback and the getter both extract the string again and return the actual values. So we can pop over here to see that. So yeah, this is the class for what we were just looking at. In the init value tree, again, I'm just creating, by calling the setters, right, we're creating those properties for the first time onto the value tree below us. So this is when you're constructed the ValueTree wrapper. It calls this function. After the data has been loaded in, it runs the process value tree. And in this case, like I said, I check to see if the properties exist, because if in some ways, this is again a versioning thing going on as well. If I've added a property to the value tree that wasn't stored in the persistent storage file, when I load that in, the property then isn't there, that new property that was supposed to be there. So in this case, again, we're kind of ensuring that those are there. And we're, in this case, again, we're setting them some default values for our size and position. In the setter, as I was describing, since I'm taking two values, the X and the Y here, I go ahead and I create a string out of it, and I set it in the value tree. The value tree wrapper has a whole bunch of helper functions. This set value function, which using the, it's a template, so using the input type, it knows what type it's storing into the value tree, whether it's a string, an integer, etc. And then the same with the getters here. Yeah, sorry, I was missing it. So here's the actual getter piece of this code. So since we're breaking it apart into those two integer values, I get it into a temporary string array parsed by using the token function in the string array class. And we split that into two values, and then we return those two values. But you can see in the getter call, I specify what is the type that I want to retrieve from that property in the value tree. And that's about it. The only piece that this doesn't show is a callback system. I'm going to open a more complex value tree wrapper. So this code is from a sample editor. And so this is the class that holds some of the top level values for a preset. And so again, you can see we've got a bunch of callbacks, a bunch of setters, a bunch of getters here, and all of the data change callbacks. You'll also see something I hadn't mentioned before. This includes self callback. So again, with value trees, if you have a listener inside of a class, and you're setting the value of something, you don't necessarily want to get the callback for that within your own class. The same thing we have to deal with user interface objects sometimes. We don't necessarily want to get notification in our text editor locally that our text editor updated because we're the ones that updated it. Anyway, so normally you probably pass false for the second parameter and true and only in special cases where you might need it. So again, we call one of these setter functions, and everybody who's signed up elsewhere for the corresponding callback will get the callback with the data there. So the piece that I hadn't shown is the piece that actually connects those two up, which is a bit of value tree code where we're handling the property change callbacks. And that's done, of course, in the value tree property change function. So we first come in here and we verify that the value tree coming in is our value tree, not one of our children. And then it's just an if statement that checks for each property, makes sure there's a callback assigned, and if so, goes ahead and does the callback. So that's the boilerplatey kind of code. And then let's go look at a usage. We'll go ahead and look at this GUI properties class as it's used over here in main. So this is just a regular juice application. I'm using the juice application base class, and then the initialize function, got a bunch of init functions in here. Init UI is where we set up the, set that up. And so, actually, let's back up and look at the root system being initialized. So we have locally to our main class, main application class. We've got our persistent properties and root properties and our runtime root properties. And you can see me calling wrap on these now. So we get the main root, and we're going to attach these to that main root. We're passing owner as the type of wrap we want to do. So we don't necessarily need the data to be there. And then the second parameter here, or third parameter here, is whether we want callbacks enabled or not. This is an optimization of sorts. With ValueTrees, you can sign up to get callbacks when any data changed, but you don't want to do that, obviously, if you're not going to use those callbacks. No need to take up extra cycles of getting empty callbacks into your code. So this is just a quick and easy way to specify whether you want to get callbacks or not. And that's that. So we attach our persistent root and our runtime root both to that main root. And then I set up my persistent properties file class, which is a class that observes a value tree and does that deferred writing that I mentioned. So we pass in the value tree that we want to watch, and we pass in the name of the file that it is going to get written to. And now anytime any activity for any properties or children of that value tree change, the file writer will defer that write and write that out there. Then again, I go ahead and I start attaching some of the other value trees that we're going to use. Got an app properties value tree, which you can use for, which sets the most recently accessed folder and the most recently accessed file. It's set, you can configure it to have any number of most recently used file entries. I'm just using one in this application. Then I have some other things in the runtime root properties. We have some other data that's nice to have available in other places in the application, such as the version, the application data path. So again, if you're in the code somewhere and you need to write something to the application data path, you can access the runtime root properties object and call get app data path to get it. So that's nice. I've also used this to manage quit. So when the application, if you try to quit the application, anybody who signed up on the runtime root properties as a quit state change listener will get a callback and be able to say whether it's okay to exit or not. Great way to capture if you need to save stuff or other things you might need to do before exiting. And then it can say it doesn't want to do the quit. It can do the save, and then it can then go ahead and invoke the quit again. So I actually use that in this app as well. So if you've edited your preset and you go to quit the app, the editor itself gets this callback and checks to see if the data's changed, and if so, it reports back that you shouldn't quit. Yeah, so given that, we've set up our main root with our two persistent and runtime roots, and now we can go back here to the UI one, and I'm going to set up that GUI properties class, wrapper class, and I want it on the persistent root because I want it written out to the application properties file. So since I have, this class has a member function that stores the persistent root properties, so I just access that class and I get the value tree from it. And again, I am creating this value tree object for the first time. So I'm the owner and I don't want callbacks. That's that. Audio settings are similar. So we store the current audio configuration settings, the audio device selected, etc., that kind of stuff in the properties file, persistent properties file. So in the init audio function here, I'm creating a local audio settings properties, attaching it to the persistent root properties, and I'm setting it up as a client. Actually, so this, that's funny. This class here is actually created in the audio player. I'm getting access to it after it's been created, because actually this is a bit of debug code here. I have a class that actually will monitor a given value tree for any changes, property changes, children add, remove, changed order, etc., and output that into the debug log so you can in real time be monitoring changes to a value tree. So this is a good example. This is client code of the audio settings properties. So again, audio settings properties actually created by the audio player, and we are accessing here as a client, and then just passing it off to the monitor. Let me grab my notes here. Been through. Yeah. Oh, the thing that I haven't talked about is a ValueTree wrapper that's also a container. I have another block of code from another project real quick. Yeah, so this is from another project, and this project is a node-based system. And so each chain of nodes is a process chain. And so you can see that the process chain properties has callbacks for nodes being added, nodes being removed, and the order changing. So what's interesting about this system here is that you modify the process chain by manipulating these value trees, and the user interface and the back end are both signed up as clients to this process chain properties and will receive these updates and then build the proper user interface and build the proper chain on the back end based on these things. And of course, there is a process node property class. So if you're a client of this node added callback, when you get the callback, you can take this value tree that was passed into you and you can wrap it in the process chain properties and operate on that. The other thing that I do with these container type classes is I provide an iterator to iterate over each of the objects contained. And this is an example of that. One of the things you'll notice as well is that the function, the lambda that's passed in here, is actually returning a bool. And this allows you to, as long as you return true, the loop will continue to process. And if you return false, it will exit. Useful, again, if you're just searching for a certain child, when you find it, you can return false and exit the code and proceed forward. The other piece that's nice about this is that if you're doing any thread protection stuff where you have a critical section or something, instead of making the client responsible for that, within this call, you can do your locking, you can operate on the list and then unlock when you're done. So that's the other benefit that it gives you. Yeah. And then just as one more example, let's look at some other client code. This is the actual editor for the editor that I'm working on. And setting up all the UI. All right, so the other convention that I use is any class that is going to do any binding to ValueTree wrappers will have an init function that the top level root gets passed into, and then you can do all your binding accordingly. One of the aspects of using this system also, of course, is you need to understand the architecture and the layout of your value trees so that you can locate the objects that you need and bind to them. Again, so for example, in this case, this editor class, I just need a local copy of the persistent properties. So I'm creating a local copy here. We're binding it to the root properties coming in. And of course, we're a client, so we're passing in as the client, and we don't need callbacks for that. But the runtime root, I want to keep around and use, within this class. So we have a member variable for that. And we use the wrap function, again, wrapping from the root because we know it's one of the branches there. We're going to be a client. And in this case, we actually do want our callbacks. And this is that system requested quit callback that I mentioned. So again, once we've turned on our callbacks, anytime the value tree property related to this callback changes, you'll go ahead and get this callback. Just like all of the, again, on the Juice UI functions, like a button, you have an on click. On sliders, you have a on value changed or something like that. We just go ahead and we assign the lambda and it does its thing. So yeah, this one does a lot of different things. So it's a good example of this code. But again, so that's grabbing the system requested callback. I go ahead and I wrap the app properties. And for the app properties, we're tracking what is the most recent file change. So when you load a new file, instead of informing different pieces of code that a new file's been loaded, you simply set that file path and file name in the most recent file, and everybody gets the callback and can do the appropriate things. In this case, I'm just using it because you might have a sample that's actually playing back, and if you change the samples that are the preset file that's loaded, obviously you want to stop playback, right? So that's what we do here. And this is another ValueTree wrapper properties. You don't necessarily just need to use it for data storage. This is really more of a control than data storage. So this is a play state. I've actually have other applications where I've got, your transport, right, which has got play, stop, pause, etc. Those kinds of things. I represent that with a ValueTree wrapper as well. And so it's quickly available throughout the system. So in this case, again, we've got a play state for the audio player. So we saw in the startup code that the audio player was creating some of its own value trees, audio settings, and the audio player properties. And so this is how we communicate with that audio player, is we set the play state here. There's also a place that sets the source file to be played back by the audio player. And that's over in some other code. Yeah, so by convention, this is kind of how the code goes in the init function. We go ahead and we wrap all of our ValueTree wrappers. We set up any callbacks that we might need to do. And then at the end of the init function, we go ahead and we initialize our user interface with all of the values currently in the ValueTree wrapper, right? Boom, boom, boom. That's all set up and good. And then I've got another piece of code here which sets up the callbacks for updating the user interface when any of the ValueTree wrapper properties changes. And that's what this function is here. We've got all of our callbacks and then their corresponding functions to update user interface. I think that's kind of it. I think questions will probably cause us to look at other pieces of code to answer those questions. But I think that's the high level of it.
Wow, thank you so much, Chris. That was a great journey. Yeah, so while we're waiting for some questions, maybe I can ask a question of my own that will go back probably to some more of the basics of just the intention of the wrapper class in itself. So what you're saying is that normally the way that convention works is that we would have these callbacks within our editor, within our visual editor. And what you're doing is you're actually wrapping this and you're moving this kind of out of your UI layer into a different layer so that all of your parameter actions and functions are all in one place collectively rather than jumbled in with your graphic data. Is that am I correct in saying that?
Yeah, I think it facilitates that, right? Again, if you push for the idea of all of your data living outside of the UI, right? And even like I talked about in my LED project, where it doesn't even live in the back end, actually, right? The back end also doesn't know about, the organization of, in that case, it was, process nodes or whatever. So yeah, so this is a great way to separate that data out and yeah, provide the other piece it does is, again, if I wanted to access my preset data from this user interface object, I would have to add some pointer to the class that contains it into a constructor, or in this case, like my init function, right? And then every time I wanted to get to a new piece of data, I go, oh, I have to add a pointer to that other class as well. So I need not only my editor class, but I need my transport class. And I have to pass 2 pointers in to this class, right? And then you go, oh, I need to have the status of the directory scanner in here too. Oh, now I got to add the pointer to the directory scanner class, right? So now instead we put all that data for those things on the value tree, we pass in the single root, and we bind to all the objects we need. I'm sure there is architecture somebody thought about in 1963 that is what I'm implementing here again. And I'm sure other, a data-driven model with setters, wrapper, it's not. But it does make it so we don't have to keep writing the value tree class stuff, right? And so that's, for me, I don't have to remember the property names of things, kind of bunch of stuff. The biggest pushback you get with this kind of thing, of course, is people talking about the boilerplate code you have to write, right? I mean, this is a small class, right? But like the channel editor class, those are some helper stuff, right? But this is the UI in the channel editor class, right? We got a ton of fields, right? And the value tree properties for this thing contain, all the data for this, and right? So yeah, building actually, let me open up the channel properties file itself, right? Yeah. So here are all my setters, right? So the boilerplate for writing setters, getters, and the property change callback handler, right? That does the actual callbacks. That's a lot of code for something like this. I could give a whole nother talk on what I call bulk editing, which is a way to take a small list. So let's say I had, like this list or something ahead of time, and how I could use a combination of global search and replace, but also an editor that allows you to record and play back macros, right? So since the bulk of the code for each of these is going to be really similar, if I have this list, I'll load it. Currently, I use Notepad++ on Windows. I'll load it into Notepad++. I'll turn on recording, and I'll, simply start doing things like, and now I end recording, and now I just play back my recording over and over again. It automatically follows what I just did for each of these lines, right? And I've filled in a bunch of that. And then you can get really tricky because of naming conventions. Sometimes it works out really well that I could do another macro where I record this. So I start recording, I go and I copy that little thing there because I know that I've, by convention, named the input variable to be the same as the constant that is used to define the property name. So I just copied that. I go back here, I go back here, I come over here again, and let's say my properties are all named, K, yeah, property ID, end recording. Now, if I play that back, it'll do that copy and typing that I did. And now I just by hand, I just have to go back, and because I probably did naming convention, I probably had a capital I. In any case, doing these large boilerplates can be very painful, but using these other techniques, you can quickly blow through a bunch of this code in like 10 minutes instead of, an hour to do it all. So, yeah.
Yeah. So like you were saying, sounds like it's also about reducing dependencies on each other as well.
Yeah.
So,
yeah. And again, so when I originally get pushback from coworkers, when I explain this all to them, their first usage of it though, right, where they haven't had to write something, but actually use it. Again, like I remember somebody had to change something in the user interface based on the transport state, whether it was playing or stopped, right? And when they asked me how to do it, I went, oh, just add this wrapper to your class and bind it on the init function and set up the callback and you're done. Right? And they're like, oh, I see. So yeah, once you get that boilerplate stuff done, super easy to use.
Great. So there are a couple questions here. Anthony Becker asks if this is available to use. Do you have an open source Hello World version of this on your GitHub by chance?
I don't have a Hello World version of this, but I'll pass out on my GitHub the A8 Manager project. That is what this is that we're looking at, and that's open source. And the latest, that's where I'm doing my latest work on it. I also had been putting it into a repo by itself, again, based on the fact that I'd had some cruftiness to it that I'd wanted to fix up, right? This project has allowed me to finally get that done. And so at some point, I will be making a repo unto itself with this and a handful of other utility classes I have.
Right. And we have another question from Eloy Marine Guategos, who asks, would you go as far as considering the ValueTree wrapper an abstraction over the whole application state and the fact that it is implemented in terms of ValueTree just to be an implementation detail?
Absolutely to the second part, because I also do work on embedded, and I've been thinking about some hefty embedded platforms I can write C++17 on and stuff like that. I have been thinking about creating something without a value tree in the background of it. Yeah. And it's absolutely, I mean, I think we were talking about earlier before the podcast, abstractions. It's all about abstractions. Yes. And again, in some ways, we've abstracted away that there's a value tree underneath it, right? Like I like to talk about, we don't have to think about the value tree-ness of it. And by thinking about it this way, you are creating, I use the term domain specific. I think that might be not quite right, but yeah, you're really thinking about what data goes together. For example, when I started adding the loop playback to this app, I had one value tree wrapper that contained data that should be stored in the persistent stuff and data that didn't need to be. But for development purposes, just to move forward, I put it all on the persistent side just to get it working. And then I went and I split those two into a settings and a config class kind of thing. So you give the collection of data more thought at some level, right? Like what am I collecting up here and how do I make access to it? What is the required access?
Fantastic.
Yeah.
And for anybody who's looking for an open source repo showing this, I've just pasted that into the chat, and I'll be sure to put it in the video description. And thank you very much, Chris. I think that's all.
Awesome.
Yes.
Thank you.
Fantastic. Once again, we have a community where we talk about all this good stuff. Come and join us if you'd like on Discord. The link to join is theaudioprogrammer.com/community. And with that, we'll go ahead and jump into our next talk. And we have Kyle Worrall with us. all the way from England. And today, Kyle is a PhD candidate at the Music Computing and Psychology Lab at University of York. And he is going to be talking about understanding how to design AI-driven music technology for increased acceptance by musicians. Over to you, Kyle.
Cool. Thanks very much. And also, Chris, that was a really interesting talk. As someone who doesn't use Juice a lot, some of it went over my head, but it was very interesting. I'll just do a screen share. I'm in the wrong view. Here we go. Cool. So, hi everyone, I'm Kyle. I'm in my final year of my PhD now, and I'm in the Music Computing Psychology Lab, as Josh said, and also part of the Centre for Doctoral Training in Intelligent Games and Games Intelligence, which is like a cluster of people doing research with regards to HCI and AI and stuff all relating to games, and also some psychology research. And that's like across multiple different universities, like Queen Mary's University of London, and there's Goldsmiths and York. So for the contents, there's quite a lot of slides. I'll try and make sure I get through it in a reasonable amount of time, but I'll just kind of discuss why I decided to do a PhD and kind of justifying it. And then I'm going to talk about two different pieces of research. The first is an analysis of interviews with 13 professional composers, where I talked about their workflow and also like their thoughts on different AI music tools and gave them examples. And then from this, we got 5 interesting insights that I hope can help emergent companies and startups sort of be more prepared for trying to market their tools to professional musicians. And then from this, I'm also going to talk briefly about Q3 Express plus Pedal, which is the expressive rendering algorithm that I, a supervisor and a lab colleague, developed as part of my PhD. And I'm going to kind of relate it back to these insights that we got from the first study. So without much further ado, I got really interested in doing a PhD when I learned about music generation for games, because repetition of audio is a very well documented problem in games. And historically, this comes from a lack of data allowance, but there are other reasons, but that's one of the really big ones. And while we have a lot of approaches that reduce repetition, it is a really evolving problem, because a lot of games are moving towards live services instead of just being like, we make the game, you buy the game, and that's it. There's a lot of games where they come out in seasons, or they come out in expansions, and they come out in sort of every 3 months, more content comes out. So games are getting longer and longer by design. And a lot of the time, only a little bit of music or no music at all is added with like each season. For example, Path of Exile is a game that averages 150 hours across like the whole playtime. That's from 260 players self-reporting. And completionists report up to 800 hours of like playtime. And the soundtrack is over 5 hours, and each patch sees some additional music. But that's a very small amount compared to the 800 hours you could spend playing the game. I really like the music in that game. It's just an example of, it's a very good example of a live service game. So procedural music generation in games is an approach where we computationally generate or rearrange data to minimize repetition and increase response time, and a lot of different effects. And the 2 images here are from Rise of the Tomb Raider and No Man's Sky, both of which use different approaches to either generate or rearrange musical content in real time to generate new music. And video games are often considered a medium well suited to music generation because they're non-linear and interactive, as I imagine a lot of sort of people in this audience might know, because it's non-linear in the sense that the player controls an avatar, and then the way they control the avatar dictates the music state in the game and the game state. But while it's well suited, it's not been widely adopted in games, even though it has been shown to empower composers, and it could be a solution to the idea of repetition being a problem. Some practitioners and researchers have highlighted limitations holding back music generation in games. So there's like a need for robust timing systems, or it all falls apart. Games are very resource intensive, and like if you drop a frame, that's not a big deal. If your music system drops, and it doesn't come back when it loops, then suddenly you've got a really big problem. There's also inconsistency in the quality of generative output and a lack of human nuance in generative output. But there is like an overwhelming lack of empirical research into how musicians really feel about AI. And that's because the field is fairly nascent. Although there has been some research looking at the ethical implications and, the paper I'm going to discuss today. And that's surprising because artificially intelligent music tech, so AIMT for short, is a promising field with great potential for creating innovation in music. And AIMT research rarely explores these considerations that I've just said. More often than not, for people who aren't aware, researchers create an algorithm. We will evaluate it using listening studies, which most of the time is music students because they're happy to do it for very cheap. And you need a lot of people to kind of do your listening studies for it to be statistically powered. They have musical expertise and they're readily available because research is often happening at academic institutes. So when this is done, we might also evaluate it metrically, looking at loss ratings or looking at like the features that we've inferred during using machine learning algorithms. We might compare that to the distribution of that feature in the training data. And after that, it usually, unless it gets commercialized, is left to command line. So musicians don't really get to look at it, or they might just see someone's put out a paper, and unless they're really in the sort of academic space, they're not really seeing it. And that's interesting because there's so much you can glean from talking to, the potential end user of your tool, that it seems a little bit maybe naive not to be talking to them. But I'll get on to why I think this is the case a little bit later. For a bit of background, there's been a lot of research looking at technology acceptance because technology has developed rapidly in the last sort of 50 years. And obviously AI music tech is a very nascent field, but there are some early models for technology acceptance that haven't been applied, such as the technology acceptance model, which is the TAM. There's the TAM2, and then there's a unified model of technology acceptance, which is the one I'll talk about more today. For the UMTA, it outlines 4 constructs by bringing together 8 different models. And it says that these 4 constructs play a significant role in determining whether technology is accepted. So there's performance expectancy, like how well do we expect the algorithm or the technology to perform? Effort expectancy is how much effort do we think it's going to take to actually get results out of it? Social influence is looking at the kind of social stigma surrounding the technology, like is it widely accepted, is it widely criticized, are there concerns? And there's facilitating conditions can be things like age, gender, experience, and voluntariness of use. So to compare this to a non-musical piece of tech in games, we can look at procedural content generation, which is the generation of visual or mechanical content. And this is a widely adopted and accepted method that uses a variety of techniques to generate content despite limited production resources. And PCG has been used in AAA, mid-core, and indie games to generate worlds, histories, geometries, weapons, stats for monsters, actually generate the visuals for monsters by piecing together segments of other monsters. And on the side here, you can see 3 games that use quite a lot of procedural generation to increase replayability. There's Spelunky, Binding of Isaac, and Path of Exile. So PCG's application has led to this unending gameplay experience for players, and they're used to support live service games where the delivery of a game's content, again, it happens as part of a continuing revenue model. It's not just we make the game, you buy the game. Examples of live service games can include MOBAs, MMORPGs, online-only games, MMOs, a lot of very popular games. And while PCG is critiqued for a lack of polish, and in a lot of ways it is criticized for generating 10,000 bowls of oatmeal. Like if you go to the dungeons in Morrowind or the Chalice dungeons in Bloodborne, things are very, very similar. And it's nice to have cohesion in generative levels, but without some kind of nuance to differentiate them, it becomes boring for the player. But generally, it seems to raise performance expectancy because it allows you to do all these really nifty things. There's low effort expectancy because you can just go to YouTube and type in PCG and then your language, and you're going to find so many tutorials. And it's widely used, so it has this kind of positive social influence surrounding it, meaning as far as the UMTA is concerned, it has been accepted. So by comparison, though, procedural music generation in games is not widely accepted. And this is why I decided to do this study, because there are some really good successful applications like the dynamic percussion system in Rise of the Tomb Raider and the pulse music system in No Man's Sky. And in the talks, there's a GDC talk for each of them. They sort of talk about how the system was designed not to affect the composer and like to make it as easy to use as possible for the musician. So it's not affecting workflow. But when you look at the earlier outline problems, like need for robust timing systems and lack of nuance to output, it's clear that with expectations, like industry practitioners are still thinking performance expectancy is going to be low, effort expectancy is going to be high. And there is kind of this negative social influence surrounding it because, well, it's kind of colloquial in a lot of ways, but the negative influence is kind of like people being afraid of losing their job or being replaced. And, you know, that isn't how the discourse is entirely now, but a few years ago, that was kind of the start of the discourse in like 2015-16 when these two systems first came out. So the extent to which they can really be accepted or seen as acceptable is really unclear. So I decided to do this study. And the reason I think that no one's done it before is because it was horrendously time consuming, as a lot of academic research is. So I conducted 11 semi-structured interviews where I spoke to composers from a variety of levels, so AAA, indie, and midcore. You know, and they all had different levels of experience, and some of them had different roles in audio or engineering departments at AAA studios. And kind of just talked about their workflows and also talked about different kinds of AI music tech. So this equated to 13 hours of recorded data, which I then had to transcribe, and then I did thematic analysis, reflexive thematic analysis even. This is where you go through all of the data, you highlight quotes, and then you kind of take the quote, you put it in a spreadsheet, and then you put tags on it. And the tags can be like noting the sentiment that comes from the quote. It's very laborious, it's very long-winded, but it gives you a much deeper level of insight into the kind of data you're looking at rather than just reading it. So from these 13 hours, I ended up with nearly 1,200 codes, which is far too nuanced. And then I eventually broadened it down into 250 codes, which is a lot more manageable and kind of the expected amount of data. From there, we ended up with 30 sub-themes, which then fit under 5 themes. Just to see on this table, you can see a list of sub-themes, the count from the original nearly 1,200, and then the thematic group it fits under. So I'm going to sort of discuss these thematic groups as the 5 insights that I think can inform startups and people developing AI music tech. I'm just going to mute and cough, sorry. There we go. Cool. So for the results, there was one overarching sort of positive insight, which was composers can see the benefits. They did discuss them. They did outline how they looked forward to AI's use to speed up their workflow, help them with their writer's block. And they could see some benefits for the games industry, like not just for themselves. But there was a lot of language surrounding these kind of benefits that also hinted that they felt it was for novices, like, oh, it'd be great if you had a music theory suggester for someone who doesn't have this knowledge. You'd be like, oh, so would that be useful for you? And they'd be like, no, I know music theory, like I'm a professional. It's kind of ego driven in some ways. Is, you know, that is the more positive sort of result though. And then the first of the 4 that are more like useful to us really is that there's a lack of standardized support across the games industry for AI music tools. Even when studios are under the same umbrella, like Sony or Microsoft, audio programming in games is fairly nascent. Like some companies still just have an engine programmer that kind of owns the audio systems. But, you know, audio programming in games is becoming less nascent. But even so, having an audio programmer that has some kind of AI background is very uncommon. So when composers talk about the idea of trying to use one of these tools for a project, it came up with this hurdle of really high effort expectancy because they were thinking, if I go to this studio and there's no one there that can kind of help me debug it because I'm not a technical programmer, what happens? Like, do we just hit this hurdle and it breaks? So that was a concern for them. The third finding was that there's a lack of understanding about what AI can actually do, which leads to a lack of trust. And across all the participants, when I asked them what the word procedural meant, which is like a fairly standard term in the games industry, there was no cohesive sort of understanding among the 11 of them. And, this sort of leads to the idea that when they don't have the right terminology to discuss these kind of things, and when they don't have the right understanding of the technology and technology is not being developed in an open way, it leads to this like a mistrust and a negative social stigma, which can affect acceptance. Another very interesting result was that the concerns among composers are not just, we are afraid to lose our jobs. They had really, really deep, multifaceted concerns, like the ethical or not ethical sourcing of training data. There was some fear of replacement in the data. They had concerns about generic emotionless output. There was concerns about authorship. So they didn't necessarily understand what pre-training was, but they'd be like, is the output of the algorithm going to sound like my work, or is it going to sound like the training data? Like, how's this work, and who would the royalties go to in some cases? They also had concerns about ownership, which I separate from authorship in the sense that who owns the output, like, and who is responsible for the output when it happens. Because they did have this really big concern for, if an algorithm is like maybe a generator is used in a game and is not widely known to the player base, and then it generates something that is, totally clashes with their piece of music they've written, they were concerned about how does this affect like the perception of them as a professional composer? Like, does it make them look like an amateur? And then they also had some like concerns regarding performance in the game engine setting. And there's a lot of different factors in that one result that can affect sort of acceptance. Some of it is to do with effort expectancy, some of it's about performance expectancy. And the last one, which I found most interesting, was that there's this inherent clash between creative ego and AI. Like, a lot of the language they were using was very emotionally charged. And when I showed them a series of 8 different sort of AI technologies for music, as composers, they were less offended by the mixing, mastering, and performance rendering algorithms. And at first, we thought, looking at the data, maybe this is just because it's performing a task that, they're not as good at because they're composers. But then when we looked at the sort of musical layer generating sort of technology, we found that there was a lot of language surrounding, like, AI can't produce a melody. Melody is an inherent emotional communication between we, the composers, and the audience, and we, the composers, and the director or game director. Whereas if you said to them, what about a bassline generator or a percussion generator, they were much less kind of bothered by that, but more bothered than they were by mixing and mastering, because those musical elements don't really have the heart and soul of kind of the musical identity. Can mute again for a moment, sorry. So what does this mean for AIMT? We could see why more successful applications of procedural music, use a methodology that doesn't disrupt composers' workflow. We can also see why adoption of music AI in industry for production workflows is higher, because a lot of these tools are doing smaller tasks. So we might have an AI that denoises and it does it really well, or an AI that does some mixing, that takes out like harsh frequencies. Whereas a lot of the compositional AI tools are trying to write full polyphonic pieces of music, and they're kind of stepping on the toes of the ego of the composer. And these are significant factors kind of holding back mainstream adoption of music AI. And then I was kind of like, what does this mean for my research? Because this was the first study I did. And hopefully I'm doing okay for time. But what it meant for me was the key findings that I found interesting were generative music is seen as inexpressive, which reduces adoption because it has low performance expectancy. AI is seen as a replacement and not a supplement, causing clash with the ego. And then tools need to be designed to affect workflow composed as little as possible, which reduces effort expectancy. So I decided to kind of do this in a few ways. The first was to model expressive performance, which is the algorithm we'll talk about next. And I kind of did this to add nuance to generative music, because that's not something I'd seen done in games yet. I also decided to design this algorithm with minimal input features, because some of the very successful algorithms in the sort of academic space are using features like score cues. And for anyone that's worked on, like, among composers, or, you know, as a composing assistant will know, we often don't add score cues to the music. Like, a lot of the time music is made in a DAW, and then when the scores are made, they're handed off to musicians. So at that point, you kind of don't need this performance modeling algorithm. And then also the tool needs to be as easy to use as possible, with little to no disruption to the user. So we built it around it being a progressive web application, but now I'm sort of exploring putting it into Juice and putting it into a game engine. So now to introduce Q3 Express plus Pedal. For anyone who has been following me on Twitter will have seen me talk about this over the last 2 years. So this is an expressive rendering algorithm, which is a machine learning algorithm that learns to render or perform non-expressive music data in the expressive way that a human does. In this case, we've used 5 neural nets. So 5 transformer models are used to predict note-wise dynamics, so like how are the keys being pressed, and 2 are being used for microtiming adjustments, so adjustments to the start and the end time of individual notes. And then we've got 2 beat-wise models, one that is looking at how does the tempo change, and like how do we affect tempo change in the way a human does it, and also can we predict when to use a sustain pedal to sort of improve the sound of the playing. And if we look at the pipeline, we decided to go minimal input features. So what we do is we take the MIDI data that they're using, we extract only the pitch, on time, and duration of every note, and then that's the only input features. We do model velocity first, and then we add the predicted velocity as another input feature, just to try and sort of power the timing models a little bit better. So it's not fully end-to-end really. And it is just using a transformer encoder. We don't need to use the decoder. But you can see it kind of outputs 2 different, it ends up actually outputting 2 CSVs, one with pitch, expressive on time, expressive duration, so like an off time, and expressive velocity. And then we have a beatwise CSV, which is predicted beat times, and then the pedal position on each of those beats, and then we reconvert that back into MIDI. And this is all done, so behind the scenes, all the composer does is put in the MIDI and everything's done, and they just get MIDI back. So if we look at the picture here, I'm going to play for you some non-expressive score music from the test data, which is a Haydn keyboard sonata. If we look at the image, you can see that the dynamics are the same. They're consistent all the way through, and all of the notes are perfectly in line with the metric grid, so the white lines. This is taken from GarageBand. And then if we look at the expressively rendered output in the bottom image, there is a range of dynamics across all the notes. And you can see that some of the notes have moved forward, some of them have moved back, even in, like, for example, these 4 notes where they should all fall, well, they all fall on the same beat. They've been adjusted for tempo, and then they've each individually been adjusted for like a note-wise level. Some notes have gotten short and longer. So it has, you can see there just from comparing the images that it's added a level of expression. So I'll just play you some non-expressive MIDI. Okay, so I feel like most people know what MIDI sounds like, and that's probably enough. So now I'll play you the CFEP, so Q3 Express plus Pedal rendered performance, and I'll let you hear all of this. you go. You kind of heard. I mean, the difference is very apparent. It might not sound like a professional pianist to some level, which our listening study did show it didn't rank as highly, but there is definitely a level of expressive performance that's been added to it. And I'll talk about the results now and talk about why that's important. So we did 2 listening studies. This is the results of the second one. We had actual professional human performances. We had another machine learning model that uses all score cues. We had an inexpressive, so completely like non-expressive MIDI baseline. We had a randomized MIDI baseline, which is I hand-coded a version of Logic X's humanized function. And then we had another machine learning model, which uses some score cues and some computational analyses that are done at runtime. And then our model with pedal and our model without pedal. And you can see from the data, we got ratings for expressivity, use of dynamics, tempo/rubato, and then sort of timing use. And in all but the timing, our model came third. It outperformed the sort of industry standard, which would be the humanized function, as well as another machine learning model. In the timing, they all came comparatively close, except for the score cue informed model VirtuosoNet, which performed nearly on par with humans. In this study, it performs less on par. In the first study, where there were just 4 systems, it performed almost exactly on par. Sorry about that. Just need to cough again. But it was slightly surprising to find that a machine learning model could perform on par with a actual human performance, but it's quite a nice insight, really, to see that, there is potential for these kind of algorithms to be used in a way that can be on par with not having to hire a performer to sort of humanize your MIDI, especially if you're doing mock-ups all the time. But another sort of quantitative analysis we did was to look at the distribution of the inferred velocity predictions for every system compared to the human data. And we only use CFE and not CFEP here because they both do the same velocity predictions. But when you compare CFE, our model, and VirtuosoNet, the basis mixer, they're both the machine learning models, and then sort of randomized baseline from Logic. The distribution of ours is actually the closest, which shows that the model has successfully learned the shape of the data. But I won't go into more of that because I feel like we're probably running out of time. So I think the conclusions to be drawn here really are, as AI music tech developers, we should really be thinking about what musicians actually want in their AI and how they feel about it, to better inform future research instead of just speaking to music students, which is something that happens a lot in the research space. When we design AIMT, we should avoid replacing musicians in the loop. And when we're designing tools, try and focus on smaller subtasks that can be really useful to them, rather than just, it's very, very interesting in research to do polyphonic symbolic music generation. But that is not something that, if you want to commercialize, is going to be as successful as some of these other smaller tools. Researchers should also focus on being really open in the design of the tools and the sourcing of ethical training data where appropriate. For non-machine learning models, that doesn't really apply as much. But this is a really good way to increase trust. So if you were doing like blog posts constantly, sort of talking about how you're doing it and what you're thinking about, and all these open concerns, that would help build trust and positive social influence. And finally, researchers would be advised to consider technology acceptance models, which is something people don't really think about or look at. Thanks for listening. There's quite a bit of literature. As an academic, that's a bad habit, I guess. If you want to know more, I have a paper that's just come out with the IEEE transactions on games, which is the considerations and concerns of professional video game composers regarding artificially intelligent music tech, alongside my supervisor. And that goes into a lot more detail and gives some quotes from the participants. And then we, alongside Alex Yin, have another paper under review, which is the comparative evaluation in the wild, systems for expressive rendering of music. but it's under review at the minute. Thanks.
Thank you so much, Kyle. That was a fantastic talk. While we're waiting for any people with their questions, I can start with my own, which is, where do you see the industry going? How do you see the industry adopting this, or is this more just identifying the problem space and not really knowing how this is going to be adopted within the industry?
Yeah, I think it's interesting because there were some, like quite a few of the participants said things like, technology always evolves, it's just part of a tool belt. And I kind of liked that attitude. I liked seeing that in people who are potential customers, really, not to be too sort of business minded about it. But I think, back when DAWs were probably just a thing, some composers were probably like, oh, and the only real way to do it is by hand. And I think as technology continues to evolve, you're sort of forced to adopt it, to kind of compete. So I think we will see more tools emerge. I think people who are more concerned with having their tools adopted by musicians will consider these kind of things. But I think there are going to be companies that are just trying to completely replace the composer in the loop as well. So I think we might see them pushed out eventually, though.
Yeah, so from your research, it sounded like it would be very difficult to remove the human element from the loop. Is that the right conclusion that you've come to there?
Yeah, like we can do things like, sort of machine learning driven humanizing, but the composer is vital to the kind of musical process. And, there's definitely, when you look at research that compares generative output to pre-composed output, there's always a difference in the results. Well, I can't say always, but a lot of the time there is a lot of difference in the results and people can tell. I think finding a way to integrate musicians is like the most important key, really.
Yeah, sounds a little bit like the invention of the drum machine. People thought that it would replace studio drummers, and it actually became a whole new tool in itself, didn't it? If you look at the 808 drum machine, when it was first invented, maybe it was invented with the intention of replacing drummers, but it doesn't have the expressivity. But at the same time, that offered certain advantages and served almost as an extension musically in a different way that we couldn't have conceived before.
Yeah, definitely. There has been some quite interesting research. The name's it's under Louis et al. And they came out in like 2020. But they did a study where they gave music novices some co-creative tools to sort of try and achieve composing. And it was quite interesting to see how it affected the compositional process. I do think it will just become a tool that people can experiment with. So,
what do you think, Chris?
So yeah, along with drum machine, MIDI itself was definitely the same kind of thing, and the truth of the matter is it did have certain impacts, right? Like studio musicians didn't get as much work anymore, right? And all that. And that's technology. I mean, I have this, I'm not cold-hearted, but, the past will be the past as we develop new tools. And there'll be different contexts where something's important and not important, right? Like I had a big awakening when my child was young and I was watching crappy, videos with them and just going, they don't care, right? Like there's audiences that don't care about the things that other people care about. And those tend to be the bigger audiences, pop music, et cetera, right? So I think, there will be an impact. As a programmer, I know engineering is going to change with these tools, right? And other people will be able to do some of what I do. But then there's another level of experience where, experience is still going to be important. Humanness is still going to be important, repetitive music, again, there, like we talked about, in editing something over and over and over again, for some people it will drive them crazy, and other people, they won't even notice that they're listening to it over. Yeah. So I think the answer is, yeah, the pop versions of things aren't going to care about tools that take jobs and creativity away, because that's not important. And then there's the quality music, media, arts, where that will always be important. And yeah, and those will be integrating the other things, as part of a framework, but the work on top of it, integrating the tools versus the tools just producing, right? Yeah, I think that'll be the long-term difference.
Yeah, I think there's an interesting insight there, like, because there is definitely experience that you don't get out of generative output, and like, different cultures experience different sorts of tonalities differently, and like, if you give 5 composers the same task, they're all going to kind of do it differently, and depending on how you've randomized your AI, it might always come out with the same thing. But there is definitely that sort of thought of different markets that it's going to be aimed at. Sorry, I got a bit distracted. My son was doing protest by playing his flute. He's like 3. I don't know if you could hear it.
We had a question from Chris Crawford, who says replacement will be hard to define. There are different layers of the music industry that can probably be replaced easier. Where do you see that line being drawn?
I think that is going to be an evolving kind of discussion. Like, I think the problem currently with the sort of ecosystem is, well, the social ecosystem at least, is that it's very lawless. It's very Wild West. Like, countries have all got their different viewpoints, different, like, sort of companies have different views. I think there will be outright rejection in a lot of ways of complete replacement. Like, artists, not just musicians, but artists like, visual artists are also not going to support tools that totally replace them. There's a lot of sort of backlash against ChatGPT already in like the writing industry. Visual artists are already very, very critical of Midjourney. Composers are openly critical of sort of music generation. I think adoption of smaller sort of models that replace specific tasks will begin, and then it'll eventually build up a little bit. But I do think by replacement, I'm sort of saying taking someone completely out of the job, which I don't think will be. So I can hear him in the background. I don't think that'll be something that really happens, like, because I think that would be very bad. I don't know.
Well, in order for the human to be completely taken out, then it would mean that the algorithm would need to do all the work, and it would need to nail the brief 100%. Very difficult for me to picture a scenario where that would even be possible. I see these tools as, I personally see the tools as something similar to what we saw with drum machines and with MIDI. So it's something that's augmented what we've done. It's extended what people have been able to do, and in the studio, as opposed, you used to have, every physical keyboard, and now you can have this in software. It hasn't replaced, and what do, right? We were talking about this before the meetup, that a few years later, we all come back and we want the hardware back again, and then we all want to sell it off, and it comes, but that my hope is that it's able to lower the threshold for some people who maybe they're in their bedroom studio and they say, I need a piano riff, and they can come up with something that is expressive, but at the same time, very difficult for me to see how that feedback, how do you even explain, like, even as humans, how do we even explain to each other, if you played a piano riff for me, it's kind of complex to be able to even convey or to express to you what it is that I might be looking for in a brief, right? Just that communication aspect. I think is so essential, and it's very essential in any creative pursuit. We had a comment from Eloy in the chat who says, as a pianist, I'm not worried about that this algorithm in its current state would play Hayden better, but in the future, if it does, he says, when it does, I'd just sit back and enjoy his performance. Yeah, very interesting topic. Very interesting, and I think the same thing about what Chris was saying with engineering. I think that it will definitely open up some doors for us in the engineering world. But as a person that's worked in a few very large code bases and also in small code bases, one thing that I find is that many times each project is nuanced. There's always an edge case, always a different scenario where there's a parameter that needs to be expressed differently or handled differently just because it needs to do something with another parameter. And now we need to think about how that's going to happen. There's always an exception. When you start taking, especially large code bases, now you have different versions and you have different, large code bases are like a Frankenstein of different versions and different things that need to be compatible with other things. And it's tough. And if AI could figure out that challenge, that would be an awesome help.
I think you said something about it. I think really what all this means, and because it was same in the music industry too, it's about raising a bar. So tools make entry easier, which then mean, like I was talking about, right? The simple things. Now advanced people, don't have to worry about the simple things anymore, but it means there's new people that can do the jobs where they used to be able to be the only ones who could do those simple things, right? But now they're made simple. The bar has been raised. And so what the beauty of that means, more people can get into it. And I think for the music tools where that really shines isn't in making an album, but I'm an indie game developer who wants to make a game, and I don't want to worry about music, and I don't have the money to spend on music, right? So if I had tools that could generate music for me, the quality of the music maybe is even less important, right? Or like we were talking about earlier, the lo-fi aspect can be played into, right? Whatever. But I think that's where the tools are going to really shine, is that it lowers the bar for entry into a lot of other things where music is complementary. And it raises the bar for the people who are more experienced, that they got to be even more experienced now, right? Yeah, because again, that's how I feel in the engineering realm. Like everything that makes jobs easier means somebody else can do that easy stuff now because there's tools, and I have to work at more and more advanced levels, right? So yeah.
Right. Yeah, you bring up a fantastic point, which is, if you look at Nintendo, a company like Nintendo in the 80s, and what they needed to do and what they needed to achieve to achieve the games that they did. And it's like now you have sometimes 1 to 2 person teams that can do an indie video game themselves, because we have such possibilities with some of the video game engines and what they're able to do. And it's absolutely amazing. And like you said, it also raises the bar for those AAA game studios, that what they have to achieve is all the more, especially if you look at Unreal Engine. I mean, just astounding what you can get out of the box with that. And it's like, now you look at the AAA studios and it's like the bar is so high now. It's so high. So yeah, really interesting to see how that's going to play out in the future. Great. Looks like we're all out of questions. Thank you very much, Kyle. Very interesting talk. Leading us into the future. I'm looking forward to seeing where it goes.
Cool. Thanks for having me.
Yeah, thanks again, Chris, for your talk as well.
Yep.
Yeah. So our next audio programmer meetup is going to, so normally it would be every second Tuesday of the month. Next month, I'm going to be at the Audio Developer Conference in London. So we're actually going to move the meetup 1 week earlier. So it's going to be November 7th rather than November 14th. So we have some exciting speakers. for the next one, and I'll be sure to announce those very soon. So for now, we'll let you go wherever you may be in the world. Please stay safe out there. Peace and love, and we will see you again soon.
Thanks, Josh.
Thank you.
See you, Kyle.
Thanks. Nice to meet you, Chris. You too.